Hi everybody. I thought it would be helpful to look at an example of a system that has infinitely many solutions using matrices. Okay, so I'm going to skip a couple of steps here and there, so feel free to pause the video and stop and work through a couple steps. Okay, so the first thing I'm going to do is I'm going to write the system as a matrix because I don't necessarily know that it has infinitely many solutions, so I'm just going to assume I'm going to use Gauss-Jordan elimination. All right, pause the video, do that. Okay, here's my augmented matrix. Now, my next order of business is eliminating the coefficient in the x column for the bottom two rows. Do that now. Before I show you how to do that, I'm going to let you know that I combined row 1 with each of these. Now there are different ways to do this. So for example, you could have eliminated the 4 by multiplying the 2 by -2. You could have used row 3 instead. So just be aware that those are the rows I used. Okay, see you in a second. So what you may notice is that although I followed all the rules that I was supposed to, I still got the same information for the bottom two rows. What this means is that this is a dependent system. Okay? Since I have -2y minus 15z equals -6 in the second row, and the same thing in the third row, I really only have 2 rows worth of information, which isn't going to be enough to solve my system for a single point, or a single ordered triple. So I'm going to go through and I'm going to figure out how I can set z equal to a and then solve for x and y in terms of a. So what I want you to do is I want you to pause the video and get the system into row echelon form. Now the entire bottom row is going to be zeros. All right, see you in a second. Okay, that is row echelon form. Now I don't have enough information to say what x and y and z are. I can't use back substitution. So what I have to say is, let's just say that z equals something. In that case, what does my second equation tell me? It tells me that y plus 15 halves a equals 3, or that y equals -15 halves a plus 3. So that gives me y in terms of a. I have z in terms of a, I have y in terms of a. I'm going to go back to my top row, and I'm going to say, well, that really is x plus 4a equals 3. I'm just making this substitution. So x is going to be -4a plus 3. So what does that mean for my solution? Well, my general solution is -4a plus 3 for my x coordinate, -15 halves a plus 3 for my y coordinate, and a for my z coordinate. I can use this to generate specific solutions. So say, for example, that z was 2. What would a have to be? Well, a would have to be -15 halves times 2 plus 3, or -12. What would x have to be? Well, -4 times 2 plus 3, or -5. So that's one way that we can find a specific point on the general solution. Now the general solution forms a line in three-dimensional space, which we're not going to graph, but you certainly could. All right, I hope that was helpful.